principal software architect at platformer, Google Cloud Authorized Trainer, and certified Kubernetes administrator. So Nilesh Jayanandana is here to conduct the session. Yes, Nilesh.
Hi.
Hi.
Okay. So I believe this is a Q&A session. So do you have any
Yeah,
questions or how should we start?
we have some few questions already. Chamod is here to shoot you that question.
Okay.
Chamod.
Okay. Hi, I'm Chamod. I'm from SLIIT FOSS. Our first question is, these days everyone is talking about Kubernetes. So what is Kubernetes actually?
Okay. Yeah. So Kubernetes is basically we call it a content orchestrator. So I think before we jump onto the word Kubernetes and talk about Kubernetes, there are a few things that you need to be familiar with. So the first thing is that if you have a big application or monolithic application, Kubernetes is not the way forward. So where Kubernetes fits in basically is that if you have a microservices architecture where you have I don't know 10, 15, 2, 3, 2 to 2, 3, 4, 10, 15 microservices, and when you want to scale them individually, and then you want to manage them, and then you decide to run your microservices as containers. So that's where Kubernetes would come into the picture. So Kubernetes would allow you to manage your microservices or containers effectively, and you can basically say that Kubernetes run my microservice uh, with 3 instances or auto scale my microservice, and it's automatically gonna take care of all of those things to you. So that's why Kubernetes has become a hot topic these days, because in the modern architecture, a lot of people are using microservices. The new software we build, they are written in microservices, and then Kubernetes makes things easier for them to run. There are other solutions as well, but Kubernetes makes things easier. That's why people use Kubernetes.
So you use so many buzzwords like containers, orchestration. Can you clarify?
Well, for starters, you work with me in my
Yeah,
organization, so
I
you
already know
definitely
these
know
things.
this.
So
Okay. Yeah. So containers. So containers is basically when you have an application, how you would normally run an application would be uh, you have to install certain set of libraries, certain set of things in a VM or if you run MySQL, what you will have to do is you will have to spin up a VM somewhere in the cloud or on your machine or wherever, and then you have to install MySQL on top of that. Or for example, let's take a common example, like a lot of the people here are from universities. So if you want to run a PHP, I think most of you using, sorry, there's a cat, that's my cat. The cat also has come to join the meetup, I guess. So
Kubernetes
yeah,
cat.
yeah. So what happens is basically what happens is basically if you have PHP, like if you're running PHP on Windows, what are you going to do? You have to install XAMPP. I remember back in the day I had to install XAMPP or WAMP, and we had to in that we had MySQL. In that we had PHP. There was this www folder on Windows, and we had to copy all the PHP files into it. So that's how we usually ran these things. Yeah. And then I remember, I don't know whether you all went through this, but back in the day, a friend of mine I saw on the chat, there was Jude here, a friend of mine. Hi, Jude. So I remember all of us, went through.
Hi.
Hi. Yeah. So I remember all of us, Jude and I, and all of us, we went through so much trouble in second year when we had to, configure WAMP or XAMPP on our Windows machines. There were port issues. There were so many issues. Sometimes MySQL is not working. But if it was containers, that wouldn't be the case. Containers is basically you would just combine all the binaries of the application of like say PHP or whatever. You would combine all of them, and then your source code, the application code, all together into one, and then you would create a template. We call that an image. And then using that image, you can run your application as a process, or we call it a container on your machine. So that's how we work with containers. I hope that sort of clarifies things to you.
Yeah, yeah. Okay. As a student, why we need to learn about Kubernetes and these things?
Yeah, well, as students, so well, there are so many in the modern industry. So from what I have seen, the cloud has become a standard now, which means that after you graduate or in your third year or fourth year when you go to internships, uh, knowing cloud technologies will be an added advantage. Which means you go to an interview, and if you know AWS, Google, or Azure, people people would look at you, give you a second thought, and then you have a higher probability of getting that job. And similarly, now after cloud, now the next hype in the industry is containers, and Kubernetes and orchestration and all of these things. So DevOps has become the hype these days. So if you know these concepts, if you don't need to run containers, if you know what Docker is, if you know what Kubernetes does, if you have that exposure, if you have some understanding, I think it's going to be a good starting point to your career. It would help you to get your dream job sometimes, or dream internship, or wherever the organization that you want to work. So I think that's definitely going to help you. Okay.
Okay.
You
Uh,
have any other questions?
yeah. Prerequisites to get started with Kubernetes.
Yeah, so prerequisites definitely would be getting started with Docker. You have to learn how containers and Docker works. So after you get started with Docker and you play around with it, and you start running a couple of, like, I think all of you university students, you have your university projects. So try containerizing the projects you wrote, or try containerizing the projects that you are doing right now in for your university. That's how I learned. So do that, and then the next step would be to try them out and run them on Kubernetes. The first step definitely would be to learn about Docker and run containers. Then only you have to Kubernetes. That's what I would recommend.
So, what are the pre-resources to learn Kubernetes?
What are the free resources to
Docker.
learn Kubernetes? I don't know, Google. Yeah, you can. Free. So there's this thing called kata containers. K starts with K. K. No. Sorry. Kata Coda. I'm sorry. Kata Coda. Katacoda. So that's an interactive learning platform for software engineers, where you have a Kubernetes playground, and they tell you how to do these things. And you know free resources, I'd say YouTube it. I mean, there are a lot of good YouTube tutorials on getting started with Docker, and then Kubernetes. Yeah, I think Docker, YouTube, and then if you have, I mean, there are no foreign or internationals here, so I mean, you can easily torrent a tutorial. So you can torrent one. I torrented. So yeah.
Also, you can suggest Kubernetes Sri Lanka meetup.
Yeah, so Kubernetes Sri Lanka meetup where we target mostly is like medium pace, like the mature Kubernetes users who has specific Kubernetes use cases. Definitely, all of you can join it, and I welcome all of you to join. So on that meetup, where we basically take just one section of Kubernetes or like one specific scenario or one specific case, and then we discuss, go into detail on that. So definitely increase your vocabulary, increase your exposure and all of that, I welcome all of you to study. You might not understand everything we talk there, but it's good. It's an exposure where you can start learning.
Well, Nilesh, there's a load balancing. I think it's not a big thing. How load balancing work
Yeah.
inside the Kubernetes?
Yeah, I think I taught you that, but um, um, so how load balancing works with Kubernetes, basically, this is a very hard thing to answer in a Q&A session. So, well, technically, the Kubernetes load balancing works with on the round robin fashion, and then you can have session affinity as well. So basically, Kubernetes, we know that we are running now containers. So in the scope of or the context of containers, you would be having multiple instances of your application. You would be saying like Kubernetes, run my Java server, and I want this server to be replicated 3 times. So you would have 3 Java servers running on Kubernetes. And what a Kubernetes service would do is basically now these 3, we call them pods. So the 3 Java pods uh, with the service in Kubernetes, they would just route traffic to all 3 according to their health. They have health checks and liveness checks and all of that. So if these pods are healthy, Kubernetes would automatically do the service discovery, and then they would just point the traffic to whatever the servers that are working. And if one of these servers go down, Kubernetes has this liveness and readiness checks, which means that Kubernetes would immediately identify that the certain server is down, and Kubernetes would automatically restart it, or schedule that server in some other place. Like Kubernetes is a cluster of virtual machines, so it would just point it, just run it somewhere else, and Kubernetes would always try to make sure that if you want 3 servers running, and then if you have a service that's talking to them, always make sure that the 3 servers would be running wherever they are. So that's how the load balancing would work. Basically, it's gonna just do a round robin search. Round robin means you just go one by one by one by one, and then you divvy up the traffic. And that's the short answer. But a long answer would include, how labels and all of these things work with Kubernetes, and there are things called cluster IP, node ports, load balancers. So I think those are a bit advanced questions which I cannot explain from I definitely would share my screen and show them a draw.io diagram and show you how it works. I mean, I can
Yeah,
do
yeah,
that if you want, but yeah.
that would be better.
Sorry, you want?
Yeah, it's better.
Okay,
Yeah, it's better
now.
to
Right.
getting started on Kubernetes, like creating cluster and deploy container.
Right. Okay.
Yeah,
So all
we
right.
got
Then what I'm gonna do is let me just close my existing windows, and then let me let me open a draw.io. Right. All right.
you don't use incognito.
Yeah, I don't use incognito. So basically, I don't search P on when I share my screen. Right. Okay. Can you see my screen?
Yeah.
Not yet.
Okay.
Not yet.
Right. Can you see now?
Yeah. I can see.
Okay. So whoever said not yet, I mean your internet connection have a problem. If everybody should be able to see it. Samod has a shitty internet connection. So, okay. So can you, Samod, you can see, yeah?
Yeah, I can see.
Uh, all right, cool. So, okay. I'll just overview of Kubernetes before jumping straight into services. So basically, Kubernetes is a bunch of virtual machines. You have a control plane. We call it master, and then we have we have worker nodes. So this is how Kubernetes works. So basically, what would happen is when you tell Kubernetes run my Java server, what I'm going to do is I'm going to basically be talking to this master server, and I'm going to tell this master server I want my Java application running, and I'm going to tell that master server my Java application requires 3 instances of my Java application to run. So master server is going to analyze all the nodes that are connected to this master server, and then master server would sort of like the Kubernetes control plane would identify, all right, so this node is has enough resources to run my Java app. So it's going to run one of my Java apps here. And then it's going to look at, again, to deploy the other two, it's going to have a look at all of these 3 again. And ideally, how it would work out is, if we have enough resources, we would have Java app running here. I'm talking about the same application. So if I have 3 replicas, I might have one running here. And sometimes the third one also could be running here instead of this one, if this one doesn't have any resources. So that's how normally the scheduling and how an application running on Kubernetes. And now I'm telling my master that I want a Java server to be run, and I want it to be 3 replicas. So we have 3 now. And ideally, let's say that this node goes down. Now suddenly in my environment, I only have 1 Java container running, as opposed to the environment that I requested. I want 3 replicas, but we currently have 1. So Kubernetes identifies this immediately, and Kubernetes would take necessary action so that it would make sure that the current environment matches the requested environment from the user. So that is how Kubernetes normally works. So in a scenario like that, now here's the other thing. So let's talk about load balancing, coming into the whole services and load balancing situation. So let's forget about load balancing for a second, and let's talk about virtual machines only. So we have a virtual machine. I don't know, you are university students. I don't know whether you have used cloud a lot or not, but there are 2 ways how we can scale an application. So for example, let's let's take donets.lk as an example. Donets.lk is the government site that allows us to look at our A-level results, which almost every year crashes when A-level results are out. So there are 2 ways how we can scale an application. So if this is the donets.lk, donet server, the first way we can build it, they give us 4 GB RAM and 2 CPU. This is the server spec. So one way to scale this would be to increase these remote resources here. You can just make this 32 GB, and you can make this one as 8 GB, 8 CPU, right? So this, we call it vertical scaling. There's another way we can scale, that is called horizontal scaling. Rather than we add more RAM and add more CPU into this existing server, what we would do is we would just clone the same one into different servers. So in this scenario, I think I might have to, in order to get 32 GB, it's going to be a lot of servers. But ideally, let's say this is the idea. So you would have exact same replicas as different servers. Now these have IP addresses. So this one, let's say that 35.10.100.1. I mean, these are hypotheticals. So this one having 2 or 12. Okay. and okay, last one. Right. So these are IP addresses, which means that basically IP address is how we reach a certain server in in the internet. So it's like an address. It's like your home address. So when we give a home address, the eBay or the AliExpress guys know where to deliver. So similarly, these IP addresses allow us to pinpoint and send requests to a certain server in the internet. So so there's this thing called aliases, which means that, or DNS entries, which means that I'm gonna have a DNS entry. DNS entry is sort of like a registry in the internet, which like say if I browse donets.lk on my website, on my internet browser, it's gonna talk to a DNS server, and then it's going to resolve that donets.lk is actually belonging to this particular IP address. So we call this an A record. Basically, we call this an A record. So those who have done, GoDaddy and etc. might know this. So basically, this is how we say, if I go to donets.lk, I own that domain, and I'm going to configure it. Everybody who comes to donets.lk, you should go to this particular server. Now, in this scenario, I have scaled my server horizontally into four servers. But in this scenario, if there are 10,000 users that are currently logging into donets.lk to visit their website, visit and look the level results or whatever, all the 10,000 requests are going to come to this one only, and this is going to crash anyways because it cannot handle 10,000 requests. These virtual machines or these servers doesn't get any requests because nobody's sending requests to this, because every time we go to donets.lk, it's just going to use in this IP address, it's going to come here. So that is the problem. So what load balancing basically does is we introduce another virtual machine in the middle, which has its own static IP. I'd say this one having a static IP of 35.10.100.11. So now what I'm going to do is, this is a load balancer. Then I can configure a load balancing algorithm. So basically, there are a few load balancing software. Example, X is another and something called F5, and those are like the major ones. So there are a few others as well. So now what I can do is I can just give this IP address here, and you can just you can configure this load balancer to just whatever the request. Now when 10,000 users now go to donets.lk, all the requests are routed to this load balancer, and then this load balancer would automatically forward the traffic equally to all of these four nodes. Okay. So what works is basically we tell this load balancer forward the incoming requests to, and then we give an array of all the IP addresses. This IP address, this IP address, and this. So it knows where to reach. When it comes here, it knows where to reach. So it knows these things. But when it comes to Kubernetes, the same scenario where we run donets with Kubernetes, let's say now in this scenario, donets would be not a VM on Kubernetes, but donets would be, we call it a pod, and donets would be sort of like a container running in the pod. So in this scenario, the pod also has an IP address. The pod can have 192.168.1.10, and let's take the same example. So we have this, and then we have this. 10.11, 1.11, 1.12, 1.13. So now we have 4 pods, which has IP addresses, and then Kubernetes, we can set up something called a service, which acts as a load balancer, and then this service would have its own IP address. So I think this service can have its own IP address, and then what we can do is the IP address this service has, we can sort of like point it to donors.lk. And now here's the problem. So Kubernetes, now say this pod goes down. Now these IP addresses are static. Even the VM goes down, this IP address, when you restart the VM, this IP address would remain. These are static IP addresses. But these IP addresses are dynamic, which means if this pod goes down and Kubernetes recreates a new pod, the IP address won't remain the same. IP address would be 15 or 18, we don't know. So now that becomes a problem for Kubernetes, because now the service will get all the incoming requests, but service doesn't know where to forward these requests to, because these IPs are dynamic. So you cannot basically hard code the service, the pod IPs here in the service like how we did here. So that's where Kubernetes has a service discovery mechanism where Kubernetes has labels. So all of these pods, we can have a label called app equals donuts. So this one also, we can have another label called app equals donuts. So you can also have another label here. So all of these pods share a common label called app equals donuts. And now in the service, we can define all the requests that coming into this service can forward traffic to all the pods that have the label app equals donuts. So it's not going to look at the IP address. It's just going to look at the labels. And then looking at the labels, it's going to identify the pods that actually belong to that service. And then it's able to sort of forward the traffic. So that's like the long answer. Okay?
Okay.
All right. So any follow-up questions, or you have anything for that?
So is Kubernetes only designed for microservices? Can't we use it without having containers?
I get your question. What?
So is Kubernetes only designed for microservices, and can't we use it without having containers?
Well, you can't use Kubernetes without containers. So that's the whole idea.
Yeah.
So Kubernetes is, we call it a container orchestrator. Yeah. So you cannot use Kubernetes without containers. The second question, or maybe the first part of the question, is Kubernetes only designed for microservices? No, not really. But it was targeted towards running microservices. But today we see a lot of people running non-microservice applications like MySQL, like Postgres, like Kafka. Lot of you can run basically anything with Kubernetes, and Kubernetes basically allows us to manage our containers, or manage our if your application is a container, Kubernetes can run on Kubernetes.
So we would love to see how to create cluster on cloud and how to deploy containers. I mean, web app for backend. Actually, we are asking for a demo.
Yeah, I was told that this was a QA session. I was okay. Right. So you want to know how to create a cluster on Kubernetes? Is create a cluster in the cloud? Yeah.
Yeah.
Is that what you're asking? Okay. So
Yeah.
so before I do that, okay, I can do that. Okay. So one question Ahmed has asked: can we use containers for front-end development? So before I do the whole Kubernetes thing, yes, you can. So one of the best things that I have learned to do was rather than rather than install all of these complicated software on my machine, I can just basically uh, run a Docker image for that, and then run it as a container, and then do development inside that container, which allows me to just have a clean machine, which means my machine won't have Python, my machine won't have Python 2, Python 3, Java versions, all of that. I would have all of those in my container instead. uh, that's very easy for me, because whenever I want to do updates on Python or Java or whatever, I don't have to worry about my libraries or whatever crashing, or libraries having dependency issues and all of those, because the container environment would be static. It's sort of like a virtual environment, so it's very easy. I recommend you to do that. uh, right. So you want me to run a Kubernetes, create a Kubernetes cluster, and okay, which cloud do you want me to create a Kubernetes cluster on?
AWS.
Don't say AWS.
GCP.
Don't say AWS
GCP.
because I don't have an account on AWS.
GCP. No,
I
Azure,
don't.
only
I can't create.
Azure,
I can
Azure
create
takes
on
time.
DigitalOcean. Or, I
Azure.
can go Azure.
Sure.
Let's go Azure. Well, you asked for it. I don't know.
Go.
I can go Azure, but
You are going to blame Azure.
is Sajitaran on the call?
No.
Yes. If something goes wrong, I can blame Azure. There's Kasun. All right. See, Kasun, how long it takes to load Azure. I mean, come on, how hard it is. Actually, this is dev.azure. I think just Google Azure.
Portal.azure.
I mean, as university students, I believe Azure or AWS or Google, you can get that free credit and run a cluster for some time. But like if you own a startup and if you don't have much money, I recommend DigitalOcean. It's like the cheapest Kubernetes solution I have seen so far. So I would recommend, if you're low on money or whatever, and you want to run production services for a startup, and you don't have much lot of network requirements and all of those things, and just want a cluster, I believe DigitalOcean is the way to go. Right. Let's go to Kubernetes Services, and then let's just create a cluster. There you go. So you can just have your pay-as-you-go subscription, and then you can just use what the hell is this? You can use a resource group. I can say use this one. I can say webinar, all of that. I'll have I'll just have one node. Then let's go to node pools. It's very easy basically to create a cluster on Google GKE or Azure AKS or whatever is very easy. And actually, this is the first time I'm creating one on Azure. Virtual nodes. I don't know. Let's just go with the normal stuff. And yeah, I mean, Kasun is on the call. Kasun, you can tell me if I'm doing something wrong.
Yeah, you can skip this one.
There you go. Unnecessary stuff. Okay, skipping.
Bad UX.
Skip it. Put disable. Put disable. Put disable. Otherwise, it will create.
Yeah. Right. So, what do I need to disable?
Go to the integration.
Integration. Okay. Hold on. It takes. Yeah.
Yeah. Yeah.
All right. So why don't you want container
No,
monitoring? I
no,
mean, normally
because
you should
it's a demo and
enable
I
it.
don't
Yeah.
want to create an additional resource. That's why I told you that. Yeah.
Right. Okay. Okay. But guys, if you are creating for testing purposes and all of that, just enable the monitoring part.
Yeah.
You might need it. All right. So create. So it's very easy to run one. And now, like while this is creating, I think this is going to get created. It's going to take about 10 minutes, so I can take up some other question. So what do you have?
Nilesh, I have a question.
Yeah, Jude,
So,
yeah.
Basically, in order to run Kubernetes, we need to define our deployment YAML files.
Yeah.
When our projects are becoming have a lot of microservices, lot of different services, it's hard for us to keep track of each individual YAML files. So I guess Helm is one of the recognized solution. But what is the recommended solution in this case? If we have a lot of like 100 services, 200 services, what is the practice?
And you want to avoid YAMLs, yeah?
No, I just wanted to know what is the best practice.
Yeah, usually, well, it depends, Jude. So when you have a lot of microservices and you maintain on different repos, sometimes you might have to have you can have a separate folder called K8s on these repos, and because not a single person would be developing all the microservices, it would be different teams. So those different teams can manage their own deployment YAMLs. That's one thing. There's Helm definitely as a package, like when you
I'm sorry, I don't hear you properly.
Nilesh, we can't hear you.
All right, so I have. You can hear me now, yeah?
Yeah.
Okay, sorry. Yeah, Jude. So the scenario is, I believe you can maintain them on different repos, and then have your YAMLs and all of that in those repos, so that different teams can maintain them. And Helm comes into place when you have all of these microservices together would be serving one application. Like for example, one app can have about 10 microservices and a front end and all of that working together. So you know the cross dependencies and all of those. So you can very easily create a Helm chart and package it, and then you can do releases using the Helm chart. But the problem with Helm charts is that again, scaling things up and managing them, it becomes a bit cumbersome, really, because there's a whole Helm's value.yaml you have to define, and then you manage it and all. Helm is basically, from what I see, is very good if you are just releasing your application to the outside, like for example WSO2 API gateway or micro gateway. So it's a solution that you would be giving your vendors to run. It's a pre-packaged solution. So all they need to do is Helm install WSO2 API gateway, and then it would just create all the config maps, the microservice, all the deployments, and all of those resources out of the box. So I think, in my opinion, Helm solves that problem. But like, to run and manage our own stuff, there's still problems with it. I mean, I mean, Jude is my friend, but I didn't tell him to ask this question. But I mean, this is exactly why we built Platformer Cloud. We are still working on it, but that's what we do to sort of like ease that problem in.
Yeah.
Yeah,
So
yeah.
currently, the only solution that I saw is like Helm, but right now we have Helm 2 and Helm 3, which has breaking changes. So it is sometimes a bit difficult. So I just wanted to know what is the current standard way of maintaining, because Helm is, as you said, it's perfectly fine, but this is not a default. Helm is not a default service that Google is defined by Kubernetes.
Yeah.
So is there anything like from Kubernetes by themselves that they say this is the way you should follow? Because if Kubernetes update their newest version, if Helm did not do that, it's a breaking change.
Definitely. So yeah, so two parts there, Jude. The first thing is the Helm. Yeah, so Helm there's a problem. So Helm 2 had some limitations. So there are people who are getting into problems with Helm updates and all of that, and then they decided, what the hell, we are gonna get rid of this Tiller server, and then we are gonna get into Helm 3. So Helm 3 is way better. But of course, there's a migration guide and all of that you have to do. But again, the problem would be that even if Google or CNCF updates the Kubernetes APIs and all of these things, what happens is that I mean, Helm won't break, because at the end of the day, what Helm would be generating would be all these deployment specs and all of that, and just applying to the cluster. But you will definitely have to update your Helm templates so that it would reflect with the newest APIs that the newer versions of Kubernetes would have. So that's still a problem, because Helm behind the scenes doesn't sort of like understand what the APIs the support these Kubernetes clusters are supporting, and then it won't automatically do those things.
Okay.
And there's another thing called Customize. I haven't used Customize, but yeah, that's also a good alternative. Yeah.
Thank you.
Customize with K.
Mm-hmm.
That's mostly with Customize. I have seen a lot of CI/CD and everything is a bit easier with Customize. Helm is basically application. It doesn't really serve that purpose. For continuous development and managing your own microservices, I think Customize would be good too.
Excuse me, I think
Okay.
you can hear me.
Yeah, hi.
If I develop in something for Windows system, so I want to. I am Linux user, so if I want to develop a software for Linux so Windows system, I must use the VM, or I must use something container. But there is a problem with the Docker, or I think Kubernetes also have problem. It is we must need a Linux. We must need a Windows machine to run Linux Windows container, and so we can't run it on our own machine, because if I use a Windows, I need I can only run the Windows Docker containers. If I use a Linux, I can run only Linux containers. So how do I do a remote development using this system?
Right. So again, Windows container comes with .NET legacy apps. So the main reason being that these .NET legacy apps, in order to run them, you require the DLLs and all of these things which Linux do not have. And we all know that Windows is a license closed system, so the code is also not open source too for people to port things and etc. But .NET Core and other applications, all of them work out of the box with Windows and Windows and Linux both. And also, what you can do is Kubernetes. You can create we call these hybrid clusters. Yeah, you can have Linux nodes and Windows nodes together. And in Kubernetes, when we tell now that the next time we run an application, like say a .NET legacy app, we want to run Kubernetes, I can tell Kubernetes, hey Kubernetes, run my .NET legacy application and make sure this application would only be run on the servers that have the Windows operating system. So then Kubernetes would do exactly that. There's this thing called node selectors where you can just label your virtual machines, like you can label the VMs that have Kubernetes Windows servers running as OS equals Windows or whatever, and then you can tell Kubernetes that to run your Windows workloads only on those worker nodes. So that's something. And then if you are going to work with .NET legacy, you can't really help. You cannot run those .NET Windows containers on Linux. You can't do that. Does it answer your question?
Yeah, thank you. Yeah, and I have another question. I am doing some Merani stack, some coding stuff, and I deploy my backend to the Vercel, and I also deploy my front end to the Vercel, and I link in to the across the Vercel. So can't I use the Kubernetes to individual backend and front end to the individual cluster containers, and they communicate both of them, because if I use the serverless function for each services, so sometimes it's horrible to management. So
Yeah.
and I use sometimes I am facing them. Last day I wrote my X Plus backend in Rust. Rust
Yeah.
as Apex Web, so it must give a very good performance. And I do some stress test today. It's give a lot of performance. So I think it's maybe better for using VPS, because I can deploy like I can deploy Rust backend like Node one, because sometimes we not hard to develop it.
Right. Yeah.
So okay, what's the solution? I can use the Kubernetes for Rust backend, and I use another one for my MongoDB or my SQL one, and connect both together. Or what is the best solution here?
So you can do that. So I haven't worked with Rust, but I know Rust can be containerized, and it depends on the cloud you use. Sometimes Kubernetes is not the answer. Like if you can use you can just spinning up a Kubernetes cluster only for a Rust container doesn't really make sense. You're paying hundreds of dollars for that. You can easily scale it up with ECS and then run it there. Or if you're using Google, you can use Google App Engine Flex. Azure also has something similar, I think Kasun can say. It depends. So, but if you're building a full-on solution where you want to migrate it between clouds or not be vendor locked, Rust definitely you can run on Kubernetes and manage it and scale it up and do all of those things. And you can also port your front end and the other services also to Kubernetes, and then or not, you can just have Kubernetes separately, and then just all of these are talking through the internet through APIs. Yeah, even on the same. Because now we are talking about you are running in Mirantis, I guess. So definitely you will have to talk it over the internet, or if it's the same cloud, you can have a VPC or whatever and talk it through internally. However, it's just managing the connection parts, yeah, the reachability and all of those things. It is definitely possible to run only the Rust thing on Kubernetes and then the rest on your Mirantis servers, and Mongo also on a different set of VMs or whatever, or you can use Mongo Atlas, or you can just run all of those in a single Kubernetes cluster. You can do that too, or you can just take ECS or Google App Engine or something like that and scale Rust there. And there's so many possibilities. It's just up to you to figure out which one suits you best.
Thank you.
Yeah. All right. So Chamindu is asking, if we work with Angular with .NET Core, can we handle it by one Docker image? You can handle it by one Docker image, definitely. Yeah, so you can do that. I mean, you can definitely do that. But the best way would be to run your Angular app as a separate container and your .NET Core API as a separate container. So that way, at the end of the day, the Angular application anyway would be running on your browser. It makes sense for you to run your Angular app. You build it. You either do a server side rendering or normal front end rendering, and then you run it as a separate container, and then you run the .NET Core APIs as separate containers and talk through the API API REST APIs or web gRPC if you're using that. So that's how you do that. Okay, right. So any questions? I see a few of my friends here. Ishmant is here. Hi guys. And
I
hi. Wala මේවට වෙන අපිත් එක්ක කතා කරන්න. අමිලදු hello.
There's a one
Yeah.
question. How to manage application logs within a K8s cluster?
How to manage application logs
Yeah.
on a K cluster? Okay, that's a good question. And a good answer. It's going to be a long answer. Right. So basically, normally applications, when you run applications as containers, the best practice is not to write logs into a log file, but rather you get the logs into standard out. And when you get into standard out, let's forget about Kubernetes for a second. So you are running a container using Docker or whatever, and then the logs are coming into standard out, which means you can just type the command docker logs and then you can see the logs. So what Docker does behind the scenes is that in your virtual machine, in your operating system that runs this container, it's going to store these logs inside a folder called varlib logs. So inside that, all of these logs would be available. So now taking that example into Kubernetes, we have this thing called cluster level logging. So in cluster level logging, before getting into cluster level logging, so same thing, without defining any log configuration or anything, when you run a pod or run a container on Kubernetes, command to sort of get the logging containers or whatever the pods that are running, and you can very easily get the standard out or standard error logs. But the moment your pod is deleted, those logs are gone. I mean, you can't kubectl log them. You cannot find them. It's gone. I can't vanished. Just like what happened to the money at the old bond scam. So similarly, so what we can do in Kubernetes is there's this thing called cluster level logging. So in cluster level logging, we have 3 parts. So the first one is called log agent, which means that each and every worker node of Kubernetes would have this log agent running, and it's going to sort of like read all the logs or that get standard out on all of these containers, and then it's going to stream into a log sync. So a log sync is basically a database where we can store the logs and then query them later. So log syncs, we can say Elasticsearch is one. There's another one called Loki by Prometheus guys. There's Splunk. There are, in Google there's Stackdriver. In Azure there's CloudWatch or something. So these are the log syncs. So you can stream these logs. You can read the logs, and the log agent would stream these logs to the log sync. And then you have another thing called a UI, where a log browser, which would gives us a UI to sort of like query the logs in this log sync and then view later. So that's basically Grafana Kibana by Elasticsearch, Stackdriver, Google again, AWS UI, and all of those things, Splunk UI, and all of that allows us to do that. So that's basically the shortest answer with logging. And then comes the problem, like a lot of legacy apps, they don't direct logs into standard out. They just write into a .logs file. So when that happens, what we can do is we call this a sidecar container. So when the pod Dano application as a container is running inside the pod, we can run another container inside it as a sidecar. And then two things we can do. The first thing is we can just tailf. In Linux, we call it tailf, which means that we are going to read that file and then print it to standard out. That's what we do by tailf. So we can tailf that log file and push it to standard out, which means that if you have configured cluster level logging, then it's automatically going to get synced with your cluster log sync, and then you can browse it through Kibana or Grafana. Or if you have, you can directly run a log agent as a sidecar itself, and rather than tailfing it, you can just read that log and then stream it to whatever the log sync you want as a sidecar agent, and then you can browse it from there as well. Like that's basically the shortest answer I can give on a webinar for Kubernetes logging. Yeah. Okay. Is that all? Do you have any other questions?
Yeah, Chamal. Actually, Chamad asking about that hands-on session as a thing.
Right. So before that, I'm just gonna answer Ahmed again. Yes, Ahmed. So he's asking how to get started with a clean PC and install libraries and dependencies with Docker and all of that, and how easy it is. It's pretty easy, really, Ahmed. Just you need to get a Docker image. Like you can very easily, if you are running Python, you can just Google Python Docker, and then you would get into the official Docker registry of Python images, and you can just start from that, and then you can just copy your application code into that Docker image, and you can build it. And then there's this thing called volume binding in Docker. So when you run it, you bind the volume of your whatever the code you have into that one, and then that's it. And you have a Python environment running. You can SSH into the running container, and then you have the shell. You have the whole code. You can edit. I think easily Google that and do that. Right. So okay. I mean, yeah, so the Azure demo, it's nothing much. You create it as the cluster gets created. I think the cluster got created. So does anyone have any other like interesting questions? The deployment is complete and that's it. So anyone have any Kubernetes good ones? I think, yeah.
Is there any way that we can set up and deploying apps to Kubernetes without writing configuration files? I mean, easier way?
That's Cloud Run by Google. So Cloud Run by Google allows us to very easily, without knowing the mechanics of Cloud Run runs using on top of Kubernetes and this thing called Knative, which is an event-driven server. Event-driven, running system. So something like Cloud Functions for Kubernetes in a cloud native way. So you can use that. Other than that, we develop Platform Cloud. So using that also, you can do something similar. So I mean, it's up to you to. There's another thing called OpenShift by Red Hat, which allows us to do the same, but it's very expensive. Who else? I think that's pretty much it. Yeah. All right. So Kasun is asking, can you explain the communication between Docker container and local environment and configuring it? Docker API and local DB server. Okay. Right. So basically, you want to do right. So how Docker happen when you run Docker containers Kasun? You can, there's this thing called network you can do. So if you have a local DB server, like in local host of the virtual machine, and then you're running your application as a Docker container, the easiest way you can do is you can run the host network, which means that your Docker container, the network of your Docker container would get binded directly into the host network of the machine. Then you can very easily achieve that or ping that DB server on your local machine from the container using localhost. Or what you can do is, I think that's basically the question. So that's how you can do that. Just run it as a host network. Okay, not good. On AWS, there's a limit on number of pods per node depending on the type of instance used for the pod. All right, I didn't know who are the AWS gurus here. So I didn't know AWS had T3 medium or etc. But normally Kasun 110 is the standard number of pods that is recommended to run on a VM. The reason behind this is so it doesn't really, in my opinion, it shouldn't really depend on the size of the instance. Sometimes it could, but it's a CNI of, yes, as Milind says, it's a CNI network limitation where, you know, when you have 110 pods and etc., you have IP tables and all the routing and all of these things. There are a lot of things that happens behind the scenes to see the magic that Kubernetes does. So and then Kasun comes in and says that Azure has a limit of 250. It depends. I think it could depend on the VM size as well, because these different VMs have different processors and different memory, which means that there are different processing powers. Yeah. So in order to go through these IP tables and all of these things, it certain sort of requires some sort of computational power. So maybe that's why they are limiting it. I'm not sure, but could be that. But normally the standard is 110 as far as I know, and apparently Azure has 250, which I might have to later Google and see how Azure handles that, because behind the scenes Azure has their own CNI. I don't know how 250. Yeah, I'm not sure. Right. So, Kasun, do you remember running a DB? Do you recommend running DB server as a container? Well, it depends, Kasun. Like, if you give enough memory and if you give enough CPU, DB is not going to crash. If you have, like, take my recently a Postgres crash, so I know this. So we were running Cloud SQL and Postgres was having a 4 GB RAM and 2 CPU. It's a VM, but you know it got a lot of requests and it overloaded and it crashed. The same thing could happen with containers. I mean, it's possible, but if you run it on Kubernetes as container, what could happen is the moment it crashes, it would restart. But the problem is there's this whole scenario where when we are not going to run a single instance container. Yeah? When it comes to databases in production, we have, you know, master or master slave and all of these things. So we have to properly configure it. There are some advanced techniques you have to do when you do load balancing and all of these things, because you can't blindly go and scale up a DB or whatever in Kubernetes in that architecture with the stand, like the old like the relational databases like MySQL, Postgres. You had to separately set up the worker nodes. You can slave nodes. You had to separately set up the master nodes, and you had to do the syncing. Otherwise, you're going to run into a split brain, and then all the data. I mean, you might have to, you know, we might get lost, and then there comes the whole backing up and all of those things. But definitely you can run on Kubernetes. We have run. So with MySQL, with Postgres we use this thing called Patroni. You can Google that. So using Patroni, we can very easily run on Kubernetes, a highly available Postgres, a production ready one. And also you can Google apps code. So if you Google apps code has these custom CRDs, which allows us to run MySQL, Mongo, Redis, Postgres, all of that in high available mode. So you can definitely look at that, and yeah, try that out. And then there are cloud native solutions like MySQL. There's a thing called Vitess, which is horizontally scalable, and you can very easily do the backups and restores and all of those things. There's another one called Cockroach DB, something similar to Google Cloud Spanner. Yeah, a lot of things out there. Just do a little bit of research, and all the SQL queries, all of them work. Okay. Any other questions? Right. Yeah. So good 1 million. So it depends, bro, on the policies of certain organizations. Now certain organizations have this thing called dev and staging should never be on the same cluster. So sometimes some organizations would have a separate cluster for dev, because dev always have this unstable stuff, and then QA and staging on another cluster, and production on another cluster. You can do that. Or what you can do is, as you said, you can have dev, QA, staging, etc., on the same cluster, and then you can namespace, divvy up them by namespaces. But here's the problem when you do that. Imagine you have the dev system and the production system both running on the same cluster. Now, dev is unstable. Yeah, you would be pushing new code, you are testing things out, and all of those things. So it could affect the production system, although we say that the namespace sort of like isolate things. At the end of the day, all of these VMs, I mean, we don't know how this is scheduled. Of course, we can sort of like say that on production workloads go to a labeled node, and then the non-production workloads could go to a set of nodes that's labeled dev or whatever. But there's a certain risk here. And then so normally I would recommend to have dev on a separate cluster, and production on a separate cluster, and QA and staging, it depends on the organization. Like I remember they were pretty adamant that dev and QA, it's okay to run on single cluster, but staging and production, those needed to be separate clusters. And staging and production, because basically staging is the pre-prod, yeah, which means that staging should mirror whatever the production system has. So so that's why they went with 2 clusters. It just depends on your use cases. And sometimes a single namespace is not enough, because now we are thinking in the scope of a single application. For a single application, that's okay. But imagine a company, like for example, let's take Dialog for an example. So if you take Dialog for an example, Dialog as a company would have a lot of products. So they would have Dialog TV, they have 444, a lot of products. So in this scenario, them having a namespace called dev, QA, staging doesn't make sense, because then so they have to put their 444 or the Papare or DTV and all of those services, all of them as pods in that singular namespace. So what they would definitely do is they would have a cluster called dev, a cluster called QA, a cluster called staging, and then in the dev cluster they would have different namespaces for Dialog TV, EasyCache, Dialog My Wallet, and all of those. So they would have different namespaces per product. So it basically depends on the architect basically of the company to define a best solution with Kubernetes for their thing. So Is that cool? That answer your question? Okay, right. Any other questions?
Yeah, there's have a time for only for 2-3 questions.
Yeah. Oh, Badagini. Yeah. Right. So yeah. I mean, I can ask about security. You can ask about monitoring. I mean, anything you have, just ask. Shoot. I don't have to type. Just unmute and ask. So if there aren't any, shall we wrap up?
Then okay. Thank you everyone for participating for our event, and connect with us on Instagram, YouTube, Facebook for more details, and we will conduct new sessions in the future. So thanks again.